Hi there. Welcome to probably the only video I'll be recording for CSCI3060 software quality assurance. Hopefully you are staying inside warm and safe. And I'm going to talk to you about introduction to systematic testing today. Up to this point in the course, we've talked a lot about software processes. How is software developed in such a way that it assures that there is high quality software coming out of the other end? But there is an extra thing that is going to be, kind of the biggest part of this course, which is given some software that you have, how do you actually know that it has that level of quality? And this is where testing comes into play. And not just testing, but systematic testing. The idea that we are not just kind of arbitrarily trying to see, is this kind of trying to work, but do we have a process by which we can give that assurance that it's quality software because we tested it in a way that makes sense. Recommendation, don't test your software only after you have released it by typing in quef 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 into your Radio Canada notification system, because then everybody in Quebec will be very, very unhappy with you. And yeah, this is a real thing. You can look it up. So, looking at software testing today, we're going to talk about the definitions, we're going to talk about specifications, and different levels of testing. Both of these are going to be super, super important to know and understand, especially for the upcoming test. And so I'll go into them in a bit of detail. Not too much, I think, but just so that you understand what they are is pretty important. So, what is the definition of testing? Testing is the process of executing software in a controlled manner to answer the question, does the software behave as specified? Now, let's break this definition down a little bit. First off, behavior, meaning that what does the software actually do given specific inputs? Most of the time, anytime you have a system, we'll take some inputs. Maybe it's people typing stuff into somewhere, maybe it's reading files or so on. Given the things that it has to start with, what does it do? Does it output certain things? Does it, make some modifications of some sort? That's all behavior. And then specification is the other big deal here. It implies that, if we're going to be testing something, that means that we have maybe a list or at least an idea, hopefully, of what it should do. And so if you remember, going back to the beginning of the course, 3 principles of software quality assurance: know what you are doing, know what you should be doing, know how to measure the difference. So the specification is what you should be doing. So to make sure that it's really important to know what that is. Now, ideally, you either are checking against the specification or you're some specific thing that you want to ensure. For instance, you wrote code and all the code actually is run. You don't have a bunch of wasted stuff that doesn't actually get used. Lots of different things you can test. And importantly, in this course, we're always going to assume that the term testing is preceded by the word systematic. And now we're not doing this kind of arbitrarily, but there is some kind of control to it, some kind of system, not to be confused with the product system, but some sort of process that we're following in order to actually test things in a way that makes sense. Now, testing is associated with 2 words that we're going to define and differentiate very importantly in this course. I'm going to shrink myself a bit so you can see them. Validation and verification. These are 2 different things that are both very related. And they are very easy to mix up, so it's important you don't. Verification is when, given some specification you have, you try to answer the question, are we doing the job right? So given a list of things that your software should do, can you ensure your software does those things? It doesn't do anything it's not supposed to. It does all the things that it should. And the way that I like to remember this is you verify facts. You don't need to get somebody else's piece of you don't need someone else's input for that. If it's a true statement that you can prove, you can figure it out yourself. And usually you do this with testing. Validation is different. Validation is answering the question, are we doing the right job? Maybe you have this list of specifications, but it's wrong because the user either didn't tell you something that they actually wanted or you misinterpreted something that they had said. So it's definitely possible that you may have some scenarios where the list of things that you've been verifying isn't actually what you were supposed to be verifying. And this is the process of validation. And the way I remember this is people validate my feelings. And this is not something that I test. This is something that I need to get others' input from. So validation, we're doing the right job. Verification, are we doing the job right? Testing makes a lot of sense for verification because if you have a list of things that need to be met, you can test it and see if it meets those things. But this is just one part of it. In addition to testing, you can also inspect code. You can see, is there actually a class that's supposed to handle a certain behavior? If the class is missing, it's not going to work. Or if you inspect and find a bug, then that's also pretty helpful to know, right? Measurement also pretty important. If your software is supposed to meet certain metrics, it's not supposed to have more than X lines of code, you can easily figure that kind of thing out. None of this requires input from your customer or from a user. You can figure this out as the developer. Validation needs to actually check with somebody. You need to find somebody who is delivering those specifications to you and say, okay, is this actually what you wanted? And if not, then you need to fix that. Testing can be used for this. It's less useful because you usually need a person to actually help you with that. But there are ways that you can use testing to help with validation. So what is systematic testing? Systematic testing, as the name implies, means you have a system. You have some set of rules that you're going to follow to match these 4 different bullet points. The first, creating and choosing test cases. Probably it's the case that just saying, I'm going to make 50 test cases. It's not really a great way to test your system. Most of the time, you're going to have some sort of system you're going to follow. Maybe you go so far as to say, I want to test per line of code. That's a little extreme, but it can work. There are a few different other ways you could do this. Maybe you have 2 test cases for every if statement, one that tests that it's true, one that tests that it's false. In any case, there should be some rule that you follow to determine how you actually make these test cases in the first place. Once you have them, then you can run them. And while you're running these tests, you need to be able to figure out what are the results of them. Did they modify some output that you need to look at, whether that's from the terminal or from a file, or they modify some other things along the way? And so any behavior that should be assessed as part of the system should be documented during your testing. And then once you have that documentation, you then can evaluate it, and you can probably automatically do some comparisons. Here is what we think is going to happen with our system. Does that match what actually happens with our system? And finally, you need to have some way to know that you're done. How do you know that you shouldn't be making any more tests? And this is where the rules come into play, because if you can have some kind of rule that you follow to say, once I've made tests that satisfy some requirement, I don't need any more, then you can be finished. It's usually not possible to completely test the system because most systems take input of various kinds, and that input could be kind of infinite in its varieties. So you usually can't test literally everything. But systematic testing usually means that you are looking for a specific way in which you want to test stuff. We call this the test criterion. So this could be, the if statement thing, where you're going to test every if statement, or you test every loop. Lots of different ways that you can do this, and we'll talk about those later on in the course. Now, specification. In order to actually verify anything, we need to have some specifications we're going to follow. So it could be that you're testing a single bit of your system, it could be testing your whole system, and each of these are going to have different levels of specification that we're going to talk about. And depending on how big your project is, depending on your software process, your development methods, it could be that your specifications for your whole project are one page. It could be you have like a very complicated series of documents, and this really is a case-by-case basis. So levels of specifications. There are usually at least 3. Move my head out of the way. Woo. And these are the most important ones that you definitely need to know. So functional specifications. These are basically the requirements. What is the whole system supposed to do when it's done? This is usually given to you by the user, and so they are the person who knows what the software should do, what it should not do, which is equally important. If your software should not allow certain things to happen, you need to test that. And if there are any restrictions on things, if I want to be able to make a user in my system, what are the rules on usernames, that kind of thing. Then we have design specifications. So now that we know what the system's supposed to do, how are we going to design the system in such a way that it will meet those? And once we have that design, how do we ensure that that actually is going to work together? So it could be the case that you'd say, all right, we're making some accounting system. We have different accounts for people. We have different customers. We're going to represent each of those with classes. And then how do those classes interact? Specifying that interaction between different classes is the design specification. It's saying, what are the different components of your software and how do they connect? And then finally, you have detailed design specifications. So now we're kind of drilling down from the top downward into the more nitty-gritty details. And this is just individual components of the code. So I have one class, let's say for customers. How does that one class work? Am I able to have a user with a specific name? Can their balance go over X number of dollars? And this should not require you to interact with other parts of the system, and so you can just test it on its own. Now, each of those levels of specification, I'll move my head again. matches with one level of testing. And so there's a one-to-one correlation for them. Our detailed design specification for an individual component corresponds with unit testing. So as the name implies, unit testing, you have one unit, one class maybe, it could even be one method, and you just want to verify that that thing does what it's supposed to do, independent of everything else in your system. Once everything has been unit tested, you know each individual part works on its own, then you can start combining them together and saying, all right, given the design specification of how some of our classes should interact with each other, we're going to do integration testing. And here we're going to verify that if two different classes need to talk to each other, maybe one of them generates a file and the other one reads it, does that interaction work correctly? And this is why it's called integration, because you're combining different parts. Then finally, system testing comes last. This matches our functional specification. So we have our list of requirements, everything the whole system is supposed to do. Does the system do it? And again, we verify this whole thing. Once we've put everything else together, we've ensured that all the individual components do everything on their own. They do everything when they work with each other. Now, does the whole system do what it needs to do? In addition to this, sometimes you're going to add acceptance testing. So this is where a customer gets involved. You usually can't do any kind of acceptance testing without the actual customer or user. And this is not verification, this is validation. Because here you usually are just trying to see, okay, we made the thing, is it what you wanted? Hence the term acceptance. So the functional specification is often going to be involved here in the sense that if we find out that the functional specification doesn't actually match what they wanted, we might want to change those requirements. But this is all only found out if we actually can get the customer and ask them to help us validate things. So in this course, for example, we're definitely going to do the first three up here. But it's probably not the case you're going to have acceptance testing because the TA is probably not going to be able to give you that kind of feedback. Okay, so when you have your specifications, you then write the tests. And this is part of extreme programming, and I think a lot of agile development in general, which is that before you write code, you should write the tests first. And the reason for that is if you know how the system works correctly, you are going to be biased most of the time. And what you end up doing is you make tests that test the software does what it already does, which you're going to pass because you know what the software does. It doesn't actually test what the software should do. So if you start out by doing what we call test-driven development, which is the specifications are the tests, you make those tests, and then once all the tests are present, then you build the code and make sure that the code matches what's actually there. It's important to do things in this order, and that's the reason that the course is structured in the way it is, so that you're not going and coding a whole system and then doing your functional requirements gathering / testing. We get all of the requirements first. We have you build the functional specification, which is what you're doing in phase 1. And then at the end, you'll actually be running the whole thing and making sure that all works. When you are testing, there are different outputs, different outcomes that can come from all of your tests. We want to figure out, there are basically two possibilities if something messes up with the test. Possibility one is that your test is actually not a good test. Maybe you have a typo in the test itself. Maybe the test actually doesn't match the specifications at all. In that case, you just revise the tests and then you run them again to make sure that now what the test is supposed to be testing is actually done. Alternatively, the test caught something that was not supposed to happen, and that's because the software has an error in it or a bug or something like that. And then you fix the software. And it's important that in either of these cases, not only do you run the tests that caught an issue, you run all the tests. Because it's very, very likely that you fix one problem and introduce something somewhere else. So anytime that there is an issue, you should run your entire test suite again. You don't remove tests that passed one time, because it's very easy for a future change to cause a previous thing that was working to no longer work. And you don't move on until further levels of development until all the tests pass. So importantly, tests don't go away. Once you have put in a test and it's a valid test for your software, you keep it around. And anytime that the software goes into production and then it gets patched later down the line, we found some other bug that was hidden or we need some new features, the tests that you had from before still stick around and get run on the software that's there. This is a big part of maintenance, making sure that as the software changes, you still are guaranteeing it has some quality to it, right? Again, this is usually automated because doing this manually is a huge pain. But assuming that your tests are designed in such a good way, you usually can do the verification efficiently just by having proper software testing methods. Now, there's a big difference between debugging and testing. You may have done both of these. It may be the case you've only done debugging so far, and these are not the same thing. So debugging is locating bugs and analyzing for those bugs when the software doesn't work. So you do debugging when you know there is a problem. And the trick with debugging is usually trying to figure out where is that bug. Fixing the bug itself is actually usually not that hard. Most of the time you can actually pretty quickly be able to resolve the issue, assuming you know where the bug is. But finding it can often be very difficult, especially if your code is really large. Testing is different. Testing is actually finding the bugs that you don't know exist, not just fixing ones that have already appeared. And this is more methodical. Debugging is usually, something is wrong, let me fix it, is a big difference between is there something wrong, which is the question that testing is trying to answer. And this is much more comprehensive. Now, it's not to say that you should only do testing and not debugging or vice versa. Both of these are kind of complementary to each other. So no amount of testing is guaranteed to find all your bugs because it's generally impossible to test everything. Maybe for some very small programs you can test all the inputs, but it's super uncommon for that to be the case. Most of the time you can only test according to certain rules. So usually we will have things like our completion criterion and stuff that will tell us when we are done making tests. And that doesn't mean that there are no bugs, but it gives us some confidence, some assurance, you could even say, that there aren't any issues. Debugging helps us when we know that there is a bug and trying to find out where it is and fix it. But doing debugging alone is not going to find all your bugs. Doing testing alone is going to help expose some of them, but then you still have to fix them, right? That's pretty much it for today. So don't forget that there's still going to be a quiz that will be released at 2 o'clock. If you're watching this after 2 o'clock, that means the quiz is already out. Don't forget to complete it by Friday at 8. Obviously, doing a mentee is part of this. Doesn't really make a lot of sense, but maybe I'll put it in on Monday at the beginning of the class to see if people actually watched this video and learned the material from it. So I think that's it for today. Thanks for watching, and I will see you again in class. Take care. Bye-bye.